Hello, this is Dr. Schrader, um, and this is the first of our topics on transportation engineering. So this is topic one, and this is an introduction to transportation. There'll be a whole series of these, and this is the first of the series. So let's begin by reflecting: what is transportation, and why is it important? And we don't think about transportation a lot. We kind of take it for granted, but it is an integral part of our lives. It's an integral part of civilization, how cities were founded, the rise and fall of empires and kingdoms and countries. A lot of it had to do with transportation. So take a moment and reflect on this very important concept. What exactly is transportation? And why is transportation so important? What exactly is transportation? Well, one definition is the movement of things from one unique four-dimensional point to another. So in this one, I've included the fourth dimension of time because uh, I can transport an idea, for example, at one particular moment in time in three-dimensional space, like right where I'm at physically now, to a future Dr. Schrader sitting in the exact same spot, but I'm still transporting these concepts, these ideas. So we do have a time element. Now, of course, that's a one directional time element only from past to future, because we don't have the physical ability right now to travel backwards in time, but I can travel forwards from a physical spot to a future at that exact same three-dimensional physical spot. So that would be the reason why time would be included in that. So if we include time, then there's basically two things that we're transporting. We're transporting physical things, people, animals, commodities, goods. That's in the three-dimensional physical realm. We're also doing virtual transportation. So that's communications, ideas. We can virtually transport money, for example. So I can transfer from one bank account to another and never ever have to touch a bill or a coin. I can transfer commodities. For example, I could trade in bushels of soybeans and transfer that from one place to another. I could purchase it in Boise, let's say, and pick up my purchase in Poughkeepsie, all done virtually. Now, in these presentations, we're really going to concentrate on physical transportation. So let's talk about a three-dimensional definition of transportation, and this is the very common one. So that three-dimensional definition is transportation is the movement of people and goods from one place to another. So that would be our three-dimensional world definition of transportation. It's the movement of people and goods from one place to another. In chemistry, matter has one of basically three states. It can be solid, gas, or liquid. And yeah, there are some other states like aqueous or kind of that solid liquid mix, like custard, for example, which has properties of both being a solid and being a liquid. It's pourable like a liquid, uh, but it's compressible like a solid. So we do have those, but we'll just assume three basic states: solid, gas, and liquid. And these three states just happen to be the conduits of transportation. So transportation occurs either by land, which is solid, by air, which is the gaseous state, or by water, which is the liquid state. So how do we transport? There's four types of propulsion. There's biological propulsion, that is living things, people and animals are types of propulsion. Uh, I can carry somebody on my back. I can propulse myself as a biological entity. I could ride a horse. So we have biological propulsion. We have mechanical propulsion. Those would be engines, conveyor belts. We have natural propulsion systems. Gravity, for example, is a natural propulsion system. Waves, that's nature moving my ship along with the waves. A current, like on a river, we'll have a current from upstream to downstream, and wind. And so these natural systems were used for millennium in transportation. Finally, chemicals. And when I'm talking about chemicals, I mean explosions. A rocket, for example, there's chemicals that combust and explode that create the propulsion to propel that rocket into the atmosphere and beyond. Several years back, there was a show that aired on the History Channel called "Around the World in 80 Ways." It was kind of a little parody of "Around the World in 80 Days." So I came up with my own list of 80 ways to travel, going from a zip line all the way to a surfboard, with 78 other ones in between. These aren't necessarily the end all and be all. So it's kind of a fun little exercise to try and think of 80 different ways to travel. So are there other ways to travel that I didn't think of here? So take a moment and step back and come up with a list of 80 different ways that we can travel. There are five basic modes of transport. The first of these is what's called highway. So highway is the most common. Pretty much everybody uses highways, no matter where, because you have to access your property. You have to go from your property to somebody else's property. I have to go from here to the corner store, so I have to use. I'm going to use highway mode to do that. Um, so it's the most common one. It's the one we think of the most, and we have to think that there's different users and different vehicles using these highways. So highways are used by different users, different types of propulsion systems for various different needs. And so we that becomes important when we get into design. So trucks are a highway user, and so that becomes important when you get up into the mountain country because of the grades. You know, they have more issues going up and down grades. So we have to think about, do we got a lot of trucks? Yes or no? Also with clearances, right? You got to have your bridges high enough that the trucks don't uh, hit them. We have to have them strong enough so the trucks don't collapse the bridge. Buses. So, and then especially with public buses, you have to have a place for passengers to be able to get on and off the bus safely. Um, so they have their own needs because they have bus stops and how they impact the roadway network. Automobiles, that's the most common, especially here in the United States. We love our automobiles. Uh, most people own at least one, if not more, automobiles, and we're a very car centric society, and there's nothing wrong with that. So we have to take into account we got automobiles, and even these automobiles aren't all the same. They're different shapes, different sizes. Some are manual shifts, some are automatics. You got Mini Coopers, you got Expeditions, so even a whole variety of different automobiles. Motorcycles. We have bicycles and other human powered vehicles. We have pedestrians, so you have to worry about pedestrians. They're walking, they're running, uh, etc. And we have animals and animal powered vehicles. So in some parts, you'll have horse drawn carriages. And these become issues, for example, when you're designing a pavement that uh, the pavement needs for a steel wheeled wagon are a lot different than a pneumatic tire car, right? And they'll interface. So, for example, I've actually driven through the Amish country of Ohio, and you have to be careful because you'll have horse-drawn carriages. and they're waiting at the red lights, just like the rest of us are. They're waiting for the light to change at the traffic signal. So if we program a traffic signal to detect, we have to worry about how do you detect horses, because a lot of detection systems have to do with metal and electric inductance, and horses aren't metal, they're biological. So how do we design around that? How do we adapt to that? So we have different users using the exact same roadway network, and we have to take all those different users into account. The second type is rail, and rail was much more common in terms of passenger use back 100 years ago. Predominantly now, rail is freight, uh, and it's still a major uh, freight transporter is rail. A lot of freight goes by rail. Uh, then you got the passenger service. And then you've got transit. So transit and passenger are not the same, because transit, you'll tend to have its own guideways. They don't run on the same tracks. The typical passenger will run on the same tracks as freight. So you have issues of who has the right of way, uh, interfacing between the passenger and the freight trains. Transit, you really don't have that. A lot of times you'll have electric systems, electric rails with transit, so they have their own unique things. You have where the stations have to be. That's also unique. And then finally, you have this fourth system, which are mines, right? Industrial uses. And those generally aren't the same gauges as other rail, but they're still a type of rail. So we have to think about all these different types when we're thinking about rail transit. Air, and we basically have four different types of air. We have what's called general aviation. That's private planes. That's smaller planes. They're not for hire. Okay, they're charter planes, but they don't have regular service. And you'll have a lot of general aviation airports. That's most common. Most of the airports are general aviation. Then you have commercial, and that's your passenger service, and they're a different beast because you have to have terminals. You have to have ways to interface to get the passengers on and off. So that's more like transit in the air, if you want to call it that. And they don't go to as many airports as general aviation does, because you have to have enough people to justify the cost. So that's your real busy airports: your O'Hare, your Kennedy, your LaGuardia, uh, your Hartsfield. Then you have freight. So you'll have some, like shown in the picture. Those are jets, but those are purely FedEx freight jets. Same size as passenger, but there are no passengers. It's completely freight. But a lot of the freight that we have, a lot of the movement of the mail is through the air, and this has been this way since air was came to be. One of the first uh, groups that helped advance aviation was the U.S. Postal Service, believe it or not, to expedite mail delivery. So mail delivery became an important factor of improving the air network. So freight has always been a major player in the air system. And then finally, the military, they have their own complete separate air system from the non-military uses. They have their own airports. They have their own air traffic control system. Everything is a little bit different for the military because they've got different types of planes with a lot of different types of needs on there. But even they do a little bit of everything. So they'll have some, they fly their own passengers, they'll fly their own freight, but they're a completely different network. Water. Water's always been an important one since the beginning of civilization. If you look, Uh, the ancient civilizations were located on major waterways because the land network was pretty much non-existent. This was the way that you were able to go long distances, were by water. So, for example, ancient Egypt was basically the Nile Valley. You could go up and down the Nile Valley. You couldn't go very far laterally off the Nile, but you could go far up and down the Nile. And you could do it pretty quickly, and you could carry lots of freight, lots of people, soldiers. So water's always been an important mode. So you have long distance passenger service. That's your cruise ships. Those are some of the ones that will cross the oceans. You have freighters. You have ferries. Ferries are interesting because they're actually an integral part of the auto network. So you can actually ferry cars or ferry people. You have barges, and what are barges? But big trains on the water. And a difference between a barge and a train is trains you pull the cars, barges you push them because of the difference in currents. They're easier to steer that way. So there's a slight difference between a plane and I'm sorry, a train and a barge and how they do things. Then you got small private boats, and of course you got military ships. And then a fifth kind of transport that we don't really think about a lot, but it is there, is continuous flow. Uh, so these are conveyors, belts, cables, pipes, conduit. Aqueducts are continuous flow. If you go into a warehouse like Amazon, for example, it's full of conveyors and belts, and they're transporting product from one end to the other. And it's just continuous flow. Even at your supermarkets, right? When you check out, that's continuous flow. At airports, you'll have those moving walkways. That's a continuous flow. So some common uses of continuous flow: warehouses, intermodal hubs like this one shown, landfills, quarries, gondolas, ski lifts, grain elevators, pipelines, zip lines, all kind of versions of continuous flow. So, what is the importance of transportation? And Jane Jacobs, in her seminal book, spelled it out pretty well. That the simple needs of automobiles are more easily understood than the complex needs of cities. That just because we solve problems of traffic, we don't necessarily solve the problems of cities. So, how do you know what's driving traffic until you know how the city works? So, there's this like uh, symbiotic relationship between land use and transportation. Uh, One feeds the other and vice versa. So it's important to know how these things fit together. Good transportation is a basic necessity. It's an economic foundation, and trade requires a good transportation network. If you got a bad transportation network, you have no trade. The purpose of cities are to provide multiplicity of choices, and good transportation is essential to provide those. So the reason why we have cities is we want to be able to have many, many choices. So it's the hub of a network, of a transportation network. And the more dense the population, the more complex the transportation needs become than if it's not so dense. Um, so there's all these links between transportation and land use. So our dilemma as transportation professionals is, how do we improve one without negatively affecting the other? And sometimes we don't think about those working in sync like that. So what about this transportation land use link? Well, as places industrialize and urbanize, your needs are going to change. Population growth, increased trade, improved standards of living, all increase demand for transportation. As a place gets denser, the modal needs change. And what I mean by modal is whether you're using a highway or air or even submodes like transit, these change. So, for example, demand for car ownership will decrease as places densify. That's because you can walk places more because it's closer together. Demand for transit increases, and it's because parking becomes an issue. Pedestrian vehicle interface increases in importance as businesses need both to survive and thrive. I mean, we can't all have drive-through. A lot of times we want walk-up business. So how pedestrians and vehicles interface become more and more important. Uh, the more urbanized and dense the area becomes, because you're going to have more conflicts because you have more people. The more space that's provided for cars, the more need for cars. Longer distances discourage other modes. So if you have to travel a further distance, you're more likely to take your car than to take other modes just because of the convenience. Uh, Reducing density makes other modes less efficient. So if you want to support transit, you have to have a dense area for transit. If you're in a spread out area, it's just not going to work. It's just not going to be cost effective. You just don't have enough customers. Easier access by car encourages their use. Parking supply feeds parking demand. Uh, yes and no on that last one. Sometimes you'll just have this inherent parking demand just because of the land use and the density. But that being said, there is a strong correlation that if I provide a lot of parking, then more and more people are going to want to drive than walk because it's easier to park. Parking does fuel decision making. Dullness of a locale encourages travel to less dull areas. If the place I live in is boring, I'm going to want to go someplace that's not as boring. Attrition strategies discourage use of cars. So, for example, if we want to encourage combining of trips by design, uh, sometimes it's okay for drivers to be inconvenienced, especially when the inconvenience is a result of personal choices. And what I mean by that is, let's say I move out to a ex-urban area. It's all two-lane roads, and now these roads are all congested. Do I really need to go and widen these roads because people made the choice to live out in an area where the transportation network was not there to support them? So we don't want to fall into that trap of people make bad choices and then we come behind them and change the transportation network to encourage others to make similar bad choices. You can use road diets, for example. That's a common practice in some urban areas. If you don't need the laneage, take it out. Sometimes you want to increase impedances. There is a relationship between time and trip route. So if you don't want people to take particular trips or to change how they take trips, then sometimes you have to throw some impedance in the way to subtly encourage that movement. So here's some factors that affect car ownership that we don't necessarily think about. Because we know if you own a car, you're going to use it, right? You're paying insurance on it. You're paying maintenance upkeep on this thing. You're going to use your car. If you own it, you're going to want to use it because it's there. If you don't have a car, then you're not going to think about it because you don't have a car. So things that impact our car ownership: household income, and this just goes without saying. It's intuitive. The wealthier we get, the more cars we own. Price of fuel. In areas where gas is very expensive, that becomes a discouragement to own a car because they become more expensive to operate. Population density. Uh, the more densely populated an area is, the lower the per person car ownership. So per capita car ownership in a place like San Francisco or New York, especially New York, is a lot lower than say Omaha. Uh, Can you think of why? Why would that be? Kind of think to yourself, why do you think that population density would lower car ownership rates? So social factors such as household income, family size, and where you live will affect the travel decisions that you make. And it's crucial to understand these connections when you talk about transportation and planning transportation improvements. Finally, a little highlight here. There are these things called roads to nowhere. And what is a road to nowhere? It's a seemingly pointless road or part of a road. Uh, and often what you'll see is you drive by them and you go, why did they build this? This is stupid. There's just this road out into the middle of the desert and it just ends. And often these are roads that were planned to be part of a larger network. But for some reason, generally a political, social, but sometimes an economic one, the whole thing was never built. So you have little parts of it that are left. So this becomes an issue in actually how we stage construction and how we plan things. If we plan a mega project and we only build bits and pieces of it, or is it really worth even building those little bits and pieces of it? We do have to have some connectivity to it. So here's some 12 interesting case studies of roads to nowhere. Probably the most famous one is the Embarcadero Freeway, which was ultimately torn down after it got damaged in an earthquake in the 1990s. Is I-70 in Baltimore is another one. Cooper Boulevard through Memphis. Uh, I-95 going through Washington, if you've ever gone through D.C., the orphan freeways of Detroit. So those are some of the case examples, and there's many, many, many others. And these are ones where part of the infrastructure was built, but the total project was abandoned. So the infrastructure either is not even used, or it's incorporated somehow into the transportation network. There's some that are parking lots, for example. There's some that are just not even used. They just end. So notes and supplemental material for this presentation are available for purchase. For more information, please send an email with the subject title Transportation Topic 1 in the subject line to the following email address, mhschrader@mhsprofessionals.com. We will see you at Topic 2.